All right, so this is going to be like a humorous, kind of lighthearted talk, talking about, how you can hack into a computer with an AI. But to begin, I kind of wanted to just take a moment and say thank you to these individuals here who, all of us are here because of them. So this is ethics-free guide to exploiting deep learning for fun and profit. I signed up for this talk, and I've never done a big talk, and they told me I was going to be speaking in a booth, so I was like, all right, sweet, because I'm not qualified to do anything. So this is me at age 11 at MIT. I actually got in trouble for messing with that computer. I've been reading 2600 since I was 11, and I've been dreaming of coming to Hope the entire time. So this is big for me. And if you're a parent out there and you catch your kid, playing with computers or reading 2600, it's going to go one of two ways, right? Either they're going to have an awesome career and get amazing experience out of it, or they're going to be on stage talking about how they pissed the government off by making AI. So also, my company wants nothing to do with this. So I work for a cybersecurity company doing AI for defense, and there's a lot of really cool stuff out there for that. But for some reason, they didn't necessarily want me associating their name with this. So in lieu of that, I reached out to ThreatBut. So now I'm a ThreatBut employee. ThreatBut is hiring. Check out our careers page. Let's see. Shouts to all these people over here. They've all been immensely helpful. And not affiliated if I get in trouble for this. I've worked on a number of ML projects. Endgame has a really cool project that I've contributed to. Just a handful of other things. And this is my site. .sh is totally a TLD, and you can have one. And if you curl that into bash, there's a special surprise for you. My Twitter is really not safe for work, and my GitHub is really, really not safe for work. So these are some of the contributors to the project. And so there was a sort of a think tank out there for adversary ML called the Warmind, which comes from Destiny 2 or something. But either way, so they are a group of InfoSec experts and researchers. You may recognize some of those names up there for other projects. And so they've kind of been looking into this, and so I have as well. And then shouts to Molly. That's not the FSF Molly. That's that Molly. She's awesome. And then shouts to x9security.com. He actually launched his page early so I could say something about it, but check that out. Okay, so disclaimers here. I'm not a real data scientist. I learned this shit on YouTube. Also, this is the most Hope thing ever because there's a PhD electrical engineer over there, and you guys are talking to the guy with the GED that learned this shit on YouTube. I'm also not a red teamer. Can't do CTFs or anything like that. So this is going to be painful for both parties. And of course, we're InfoSec professionals. This is purely a research project based on what's this going to look like in the future? Is this possible now? And kind of just, we'll sort of go into that. And then, don't do anything illegal because of this talk. So. So, every talk kind of has an agenda. I wanted to throw mine out there. This is the stuff you have to get through before you watch an AI pop-up box. I'm going to do some software freedom talks related to AI, the current and future state, stuff like that. And then there's going to be 20 minutes of me being whoa, TensorFlow is cool. AI liberation. So this is a neural network. Oh, I'm sorry, this is a printing press. And kind of, hopefully everyone here, hold on, let me scroll down on Emacs real quick. Okay, so everyone kind of knows the story here, right, where there's this person named Gutenberg in like the 1400s who designed this thing, and before then only like 6 people in Europe knew how to read. And then, they started releasing books, and that rate skyrocketed, and because of that, people could read the Bible, whereas before their priests or whatever were the only ones that could, and Protestantism happened. But what they don't tell you, or at least I didn't know, so I was looking up what a printing press costs, because I was going to make this really lame point of like, oh, it wasn't free, so normal people couldn't have a printing press. So fun fact, like $5,000 today money, but that's not the interesting thing. The interesting thing is that Gutenberg never sold the printing press. He kept it a secret. So if you wanted a printing press, you had to take $5,000 just of material and then spend like your entire life apprenticing and mastering this thing, working in a shop, memorizing every single component and how they worked, start your own shop and build one from memory. And for 200 years, that's how we did printing. It was a secret. So then, that's such a good picture. So this guy came along, and I hadn't heard of this individual, Joseph Moxon. So it turns out Joseph Moxon in 1683 was the first person to publish plans and instructions on how to do printing on a printing press. So it took us 200 years. So like, think about that, right? So Gutenberg, whose name is literally synonymous with information freedom, was like Microsoft in like the mid-80s, right? And then this guy, of course, is like the RMS of like the 1600s. Shouts to RMS. So, but the really cool thing about Joseph Moxon, like I went down this crazy Wikipedia rabbit hole one night doing this. He didn't just do the printing press. This guy was self-educated. His father was a tradesman, he was a tradesman, but he just liked messing with stuff. And he wrote like our first guide to the printing press, obviously, but also some of our first books on like woodworking and like weird, like abstract old-timey math. These titles are great, like Mathematics Made Easy, spelled all old-timey. But I guess, so my point is, right, is that Joseph Moxon was an OG hacker. He took this thing that he had the foresight to see is going to be, or already saw, right, was incredibly important to our culture and how we grew. And he knew that needed to be free, that needed to be a public resource. Fortunately, nowadays, free and open source software is kind of the way we do things. And so with artificial intelligence, this technology that's affecting everything in our lives, we have the bleeding edge. Like you can go download TensorFlow right now, and they use that shit in the drones, in drone research. I'm sorry. So like that's kind of what this kind of rant is about, right? Is that we have this right now. We can learn this. I learned this on YouTube, and I have a GED. Like a lot of you are really, really smart people. All of you are, and like we need to start hacking on this stuff. So why don't we? Well, there's a lot of uncertainty right now. It's the current narrative of artificial intelligence, or whatever word we want to call it, is that it's really scary and that people can do really bad things with it, like make AI that can pop boxes. And so we get a lot of crazy news like this, and this, and this, and it's honestly like I'm not trained in this type of thing. But like, if you know like the first thing about a computer, you know that this is ridiculous. It's not even part of the story, and it's not even boiled down to something that non-tech people can understand. It's just absolute garbage, and it's not the truth. And then you get stuff like this. This article came out like a week ago, and it's my favorite thing ever. So top line, right? Microsoft calls for AI regulation. Bottom line, we're totally buying into it. And then this guy, right, Mr. like AI FUD himself, is saying it's more dangerous than nukes. It's an existential threat. And then he goes and does this shit. And that's the story all over is, we as normal people who have access to this shouldn't have access to it, but they totally should, and let's buy in and regulate the hell out of it. And then the marketing to make AI less scary, they're not advertising like mass anomaly detection or crazy Bayesian networks to track you. They're doing stuff like this. They're teaching them to play Dota, which is impressive because I'm an LOL player. Dota's real hard. And then they do stuff like this, right? This AI chatbot that talks to your kids, and oh, that's super cute. And then this even cooler AI chatbot that talks to your kids. So this is kind of summing up the point here, right? Is that the? Oh no, I lost my notes. This is like my first talk. So those who would profit off of making this inaccessible are benefiting from us not knowing anything about it, and at the very least benefiting, in some cases, like contributing to it. Come on. So let's kind of cut through some of the uncertainty and doubt and things like that. What is AI? Now, if you talk to like any grown-up data scientist, they'll probably not call it AI. I call it AI because I really love cyberpunk, and it sounds much cooler than deep learning, I think. But so the general gist of this thing, right, is that AI is a really old term, and it's any computer that can kind of emulate tasks. So like something that can play Pong against you is artificial intelligence. It's something that emulates human intelligence. Machine learning is when an algorithm adjusts itself based on previous knowledge or trained knowledge. And then deep learning is when you use these like deep neural networks to do these wild convolutions and things like that. So that's kind of the gist of it. You'll hear them all used kind of interchangeably, and that's kind of how it is right now. So what can they do? What can they cannot do? So they're very good at things like classification, right? Hot dog or not hot dog. Things like regression, predicting if a customer is going to churn or not, or predicting like the price of a house based on certain data. Clustering, so your social network is a cluster. You know someone who knows someone who knows someone. You all happen to share a certain hashtag. And then learning inductive bias, which is a big academic word that I can kind of sum up as it tries things and then figures out why it succeeds and why it doesn't. What is it not good at? It's not good at decision making without rules. You need to write the code. If you saw the code for the upcoming demo, it's like mostly, all right, go here, now go here, now go here, now do this algorithm that you figured out. They're not good at unstructured thought. We don't have general AI. They can't broadly infer things. And data's really, really messy, and it's a real pain to kind of herd into, encapsulate and scale it so that you can train models with it. So defensive AI is really big business. It's a big buzzword, and everyone's doing it. I have like a Splunk sticker on my laptop, shouts to Splunk. But like, everyone's doing it to some degree. And some of these, I'm not like pointing fingers, but some of these are very loosely what we would consider AI. They're like very good statistics algorithms. And then some of them, shouts to the Canadian government, are doing very deep, interesting studies into it. But who's looking at offensive AI? Who's looking at things that can attack and make decisions adversarially? Well, and this is real dramatic, I'm sorry. Anyone in this room considers evil is probably doing it, depending on who that is. So let's make one. Oh wait, I wasn't supposed to say that yet. So we'll so what's going on in today's world, right? Well, there's some existing projects. Some of these are deep learning. Some of these are artificial intelligence. Some of these are really cool graph algorithms. Endgame is doing a lot of studies into this. They've contributed a whole lot to both sides of the artificial intelligence in cybersecurity communities. Bloodhound is not traditional deep artificial intelligence, but I would argue that Bloodhound and even things like Maltego that can do deep graph-related correlations are, to some degree, artificial intelligence. And then there's deep exploit. So deep exploit, they're a very similar project to this project, and they're presenting at Black Hat. And hey guys, deep exploit, if you're watching this, I challenge you to an AI fight. They have cooler ASCII art than me. So let's talk about really scary things now. So what are some scenarios that we kind of have to actually be worried about? And it's not Skynet. OS-Inc correlations. ML right now is very good at correlating things, and it's just going to get better. We don't need as large of data sets to train on as we did before. And we can scale and handle more and more powerful pieces of software on our normal computers. And so adversaries and bad guys and the government are going to be using this to correlate all kinds of things. What times do you normally tweet? Well, that gives away where you live. What dialect do you use? That gives away specifically where you live and what community you're involved with. Things like that. OS-Inc crawling. Telemetry is really interesting, so you can train a network on someone's speech patterns and then de-anonymize them. So if you have, say, someone posting hate speech and you know their Twitter, well, all of a sudden now you can find them on the things that they don't want you to know. And traffic analysis, pattern recognition, things like that. Deep social engineering. Also, shouts to Chelsea Manning. I'm really stoked to hear that she's playing with TensorFlow and things like that. It's very exciting, but she brought up deep social engineering in a way that I hadn't even thought of. So sentiment analysis, as in you take all the tweets about your company and figure out if people like you or not, is a real common use case right now. But we can arguably potentially use this in reverse to figure out who is saying negative things and give that an impact and figure out why that has more of an impact than other things. Figure out certain terminology, certain phrases in certain communities where you can have the most impact to essentially socially drop these things to spread and reduce the sentiment of an organization. Psychological factors, we're already doing this, but we can determine an individual's needs, fears, and vices just from your Twitter feed. And mass scale psyops and mimetic manipulation, which Chelsea brought up, which I thought was very interesting. So take that times 10, it's what Twitter's doing. They're manipulating your feed for better or worse to get you to respond more. And in doing that has been proven to make people depressed and anxious and things like this. Automated phishing, that's also cool. And intelligent persistent threats. So the deep Q algorithm, and I'm probably totally wrong on this, but that's what AlphaGo uses. But we can actually gamify network penetration, which is kind of what this project is attempting to do. We can analyze targets, attempt to avoid being detected and blend in. And the really interesting thing is that in AI APT, which sounds like something that ThreatBut would come up with as far as a term, would be extremely difficult to attribute. If one of those things gets loose, you're dealing with a model and some Python code that's branched out. So anonymous actors, statistical attack modeling, behavior emulation, and that's really scary, and let's build one. Okay. So I'm going to explain how deep learning works real quick. So it's actually really simple. You start with a neural network. This is actually a neural network. You do some back propagation once you push the data through. You have some stochastic gradient descent and some goal reduction phase. And then this is a tensor, and you put this into a TensorFlow. And then you get some deep learning. And then you do some science and some physics. And then you do some code. I actually wrote that. And you get some more memes. and now you have artificial intelligence. So I'm obviously a real big William Gibson fan. Please don't sue me, William Gibson, because I used a bunch of your names in this. But the idea of this book, and if you haven't read this book, don't take anything else away from this talk. Leave now. Go buy Neuromancer, because it's amazing. And I'm going to grossly sum up Neuromancer to offend any sci-fi nerd. It's two AIs fighting. And so, being someone that works on defensive AI, we started thinking, well, that's kind of neat. We have something that's defensive, and training data is very hard to get, especially for defensive AI. We're dealing with I'm probably not allowed to talk about that. Dealing with data sets, and you have limited data sets. So we were using automated scripting and other things to generate data, trying to pull from different repositories, shouts to the Canadian government, and trying to label this data so we can build correlation engines and things like that to categorize attack data. So I said, hey, I was in the office super late coding, and I just read Neuromancer, and I said, hey, let's just make an AI that can do attacks, and then we have two things to train against each other. It's a generative adversarial network, such a buzzword. Plus it's awesome, Neuromancer. So it turns out when you go to your boss, actually my boss is really cool, I'm not gonna name his name, but he was stoked on it, but everyone else was really not stoked on it. Apparently, you tell individuals that you want to put a hacker AI in their network, and they get all, oh, don't start Skynet. And so this thing's open source, and I'm not allowed to name my company anymore. So you start by saying what you want, right? So we wanted it to behave like an actual actor, analyze the network environment, and use deep learning to determine which are the best points to attack. What would a bad guy do? So this is kind of what the thing looked like initially. You have Nmap. Hopefully everyone here knows Nmap. If not, it's a port scanner thing. You scan the ports of a machine, and then you get all this data, and you have a trained model. That's what that is. That's a neural network to take that data and make a prediction on what the best attack in MSF would be. So that's really cool, but it turns out someone already made it. And it's called a Vuln scanner. And so I made a shitty Vuln scanner. So I actually came up with this incredible algorithm to determine the math words of that to replace this entire project here with one line of code, and it's a SQL join. So I took. So the NIST provided everyone with the CVE database, which is sweet, and Rapid7 provided all of us with Metasploit. So you parse through Metasploit, pull the CVEs out of Metasploit, do a join, and now you have a table that tells you essentially what CVE is tied to what Metasploit module, the platform, the version, all the other data about it. I think I missed one. No. Oh yeah, arrows. So WinterMute is kind of what we called this project. And here's the questions we're asking. So from historical experience, what's the best thing to do? From environmental data, what affects that? And network architecture knowledge, what lies behind the port? If it's a if it's a MySQL, well, there might be some other things behind it. If it looks like an AD, there's definitely an AD behind it, things like that. So let's talk about the tech stack. I'm a coder, so I really, this is my jam here. So I use Python with TensorFlow and Keras and Pandas. Those are all ML or big data related libraries. TensorFlow is used for machine learning and working with tensors. That's a math thing I can't explain to you guys. And Keras is a deep learning library that wraps TensorFlow and makes it easy for people like me to do those math things. And that is, Scapy, which is a security Python library. You can craft packets and things like that. It's very cool. And then we Dockerized that. That's the best Kali logo, by the way. And we threw in a graph database, which we'll be talking about in a minute as well, to do these correlations. So here's kind of the architecture of the thing. We have a reconnaissance mode. It's given an initial state, i.e. a ping scan. It's scaled, analyzed, and all of the useful data is tokenized. So you take the data, you encode it, hash it, and now you have a token. And then it looks it up in this graph database, i.e. the join table. And it decides on a subsection of the targets, as in what's the most interesting once they're scored, and it moves in. So it does this a couple times, and it might find that a target is less interesting than the larger picture, and it might back off and look at other things. And it attempts to maximize the interest rating of a target. Once it's zeroed in on, it's given a score to say how likely it is to be vulnerable. We went through this, target is selected. I'm like reading off of my thing now. It's added to a graph. Graphs are cool. And then the exploitation phase. They're sorted by how useful or how likely the exploit is to be happening. It's executed, it attempts for success. It's a reverse shell right now. Once it's found, it'll open a sub-process and connect it. And then post-exploit, we have a data gathering script. The logs are parsed by an automatic log scrubber, which we're adding machine learning into, that can find anything that looks sketchy in the log and remove it, and profit. So here's some fake stuff. So this is called Quine. We're attempting to copy the ML over to the hacked machine so that it can escape and become autonomous, and now you have an autonomous AI botnet. I had a reporter today, or a couple weeks ago, use the word "that is scary" when describing that, which I loved, and sci-fi nerds. And then we have a simulation piece, which is it's currently in production. That's incorrect. But the simulation piece, we can design a simulated network and run through hundreds and hundreds of tests just through simulation and not actually having to like spin up VMs to do this, because the state and the environment and the agent are all separate pieces. So it's kind of like Ender's Game, where he didn't know he was in a simulation. That's a really, really dark example. So here's kind of how the reinforcement learning piece is going. So you have your agent, that's awesome.jpg, and you have your correlation engine and your network interface. And it finds things it can see, and it correlates them. And then it's given a number of decisions on a graph, and it'll say which action to take, attack and scan, which door is the likeliest to work, and which will lead somewhere. How do you ask those questions? How do you tell a computer to ask those questions? That's a tough thing. And computer science actually has a really interesting answer for that, and it's just try some stuff. AI. So that's the talk. Does anyone have any? No, I'm kidding. So it's just try some stuff. So hey, let's try struts. Oh no, they patched. Let's try Nginx. Oh no, I got caught. They have a good SIM or something. So it gets reinforced. That's the squirt bottle. So it says, all right, like let's try Eternal Blue, which you should try first if you're doing this. And it gets a cookie. So the next time it goes to ask these questions, it stores these in a math and stochastic matrix. Is that right? Or, okay. So and now it has correlations, and it can remember what these things are, and it says, oh, hey, Eternal Blue worked really well last time. So this is kind of how the architecture works from a high-level view. We have an environment, which then gives out a state and a reward. Here's some math for you. State is S, and reward is R, and in machine learning, policy is naturally Q. the policy is the state and the reward, and it maths and comes up with an answer and it hacks the computer. So, demo time. Oh yeah, heads up, I'm like real big into curses, so this is, this is almost like ridiculous amounts of ASCII art and curses. Oh wait, hold on. This thing is how do I use, computers, they're hard. There we go. All right, cool. That's cool. So, curses. Oh, I wish the text was bigger. So, we're executing our initial Nmap scan. It pulled my adapter information. By the way, I have a capture the flag box. So it pulled the ports on the CTF box. And now it's doing it's decided on which scan it needs to do based on what it's pulled already. And so it's doing a more intensive scan, probably like an SV to get the version and things like that. And now it's doing version detection matching and checking correlations and exploit mode. And we open Metasploit. This sometimes doesn't work. Exploit completed, no session was created. So the first one failed. So it's going to probably try the next best thing or maybe go back to recon at this point. There's a timer, so any minute, bud. There we go. Okay, so we're trying it again. It normally gets it within like 2. I need some like synthwave music or something. This is. Okay, so it popped the exploit. It's got the connection. It's trying to open a reverse shell. This is very intense. And we have a shell. So there's an open Wi-Fi network called Pineapple if anyone wants to jump on and have a free pen test. So what did we learn? Machine learning is hard. Specifically handling messy data is very hard. The libraries for talking to the MSF RPC are dated, to say the least. So we've kind of been contributing back to them, so hopefully they should be like Python 3 point whatever compatible now. Old solutions are oftentimes better than new solutions, and I was just saying to someone, if I didn't want to do ridiculous sci-fi crap and I wanted to build this for real, well, there's so many better solutions out there right now that don't involve artificial intelligence. Johnny Christmas is talking about, what is it, Empire Death Star? Autosploit is ridiculous. Shouts to Vector. But actually, doing this clustering thing was actually really, really fast. Our vulnerability scanner is like crazy fast. And reinforcement-based techniques provide some interesting responses that are kind of more general solutions right now than tailored solutions. Developing or teaching ML to hack a network to use these tools is almost kind of like teaching a toddler to drive a car. Like, even if you get them to drive the car, which is incredibly dangerous, you're basically just you're pushing them along every step of the way. And it turns out that when you go to the bar and you're talking to someone and they ask you how you're doing, and you say, "Oh yeah, I'm just teaching AI to hack a network," they leave. There's some spin-offs, some side projects that have come out of this. Soapy, Ecotech developed this. It's a pretty cool Python scrubber that can scrub all kinds of system logs. These two things I made are like empty GitHub repos, but I promise they're going to be happening soon. So Demosthenes is that graph database related correlation engine for vuln scanning. And then I'm dropping like soon, like add this on your GitHub now, the MLSec notebook, which is kind of just, again, to reiterate to the point here, this stuff is easy. You can literally learn on YouTube or like $10 on Udemy, Coursera, things like that. And this is stuff we need to be playing with because this is affecting our lives. And the powers that be want this to not be in our hands. And we need to start messing with this stuff more and more to kind of get a glimpse to figure out what to protect against, because all of us are totally law-abiding here and everything. So again, cite, curl that into Bash, Twitter, and GitHub. Certainly appreciate it. Thank you. Does anyone have any questions? I don't see. I can't see. Please, only easy ones. I'm not a data scientist.
So my question is, do you want help with Quine? Because that sounds like a lot of fun.
Yeah, totally. That's so. I'm truthfully. I'm at the point now where I've kind of done my research. I've kind of done the thing. And I'm not currently going to be working on this for a little bit, but Quine is something that I want to develop in a more sort of broad distributed computing sense. So yeah, hit me up on GitHub or Twitter, or we'll chat.
Cool. Thank you.
So imagining a future in 5-10 years when neural networks are so much better and amazing, what do you imagine doing? What do you want other people to be doing?
That's a good question, and actually, and I'm probably grossly wrong on this, but from my understanding, the neural network, by the way, we're in a room named after one of the people that developed the neural network, Kathleen Booth. It's an old idea, and it's just the hardware that's improving, and so we're dealing with a lot of problems in security based on, we have really good hardware, and like you can get like 9 CUDA cores for like 10K or something now. So as far as the next step and what to kind of be doing with these things, I don't think we have the answers yet. I think just playing around with it and figuring out things like this, there's ML News and Archive, ARXIV, I think that's how it's pronounced. Like those papers that come out, we're doing stuff that's mind-blowing every single day. So I can't be the one to tell you that.
Hello, thank you very much for a really amazing talk. I'm glad you mentioned about the sort of emotional and social manipulation bit that you brought up. Have you thought about have you had any thoughts about AI defenses against that at all?
Defensive against the social piece?
Yeah.
No, that's an interesting idea. What did you have any ideas based on that? Like, what would that look like?
Not personally, no. I know it's a bit sort of off topic. I just wondered if you'd thought about it at all. That was all.
I haven't. That's super interesting, though.
I just want to also say thank you for bringing back some of that old school hacker enthusiasm into your talk.
Thank you. Thank you.
I don't want to go all Debbie Downer on you, but I do have to say that some of what you're showing, ultimately, if you can extrapolate 5 to 10 years out, the percentage of people that are really going to know how to manipulate this stuff is going to remain super low, and the companies with the billions of dollars are going to be the ones developing it. Do you have, in your mind, any thoughts about how to keep something that's fun when it's like the cool kids that are using it from turning into some sort of authoritarian nightmare?
Specific action-wise, I don't have any specific thoughts other than we need to keep on playing with this stuff. We need to teach people that it's not some sci-fi algorithm word thing that someone needs to have like a high school degree for. Education is important. It's really fun to play with, and I think that if we encourage the hacker community to start messing with this stuff, I think people will. I've confidence in that.
Okay, I was reading The Doomsday Machine by Daniel Ellsberg, and one of the biggest motivations for developing the atomic bomb was the fear that the Nazis were already pretty far ahead in developing it, and even though chances are it probably wouldn't have developed if we hadn't had thought that. But the truth was, do you see us possibly bringing something into manifestation that wouldn't have otherwise existed?
Interesting. So I personally believe that you can't stop technology. You can slow it down. Someone would have had that. Someone would have figured it out, even if we weren't. I think it's important to research this, and I think it's important to do so with a very level head. And I think it's important to keep technology in the hands of the people. I say that, but please don't go home and make any explosives, please, please.
Hello. Why Neo4j in
Because
comparison to other graph databases?
I didn't know how to use it and my job wanted me to learn it, so.
Okay.
But specifically the Neo4j piece, actually that was legitimately the reason. I just found it very interesting. I like the visualizations, they're all animated and stuff. I could have probably done the same in like a dictionary in Python or something, to be completely honest with you.
Getting from GED to ML researcher, what were the most helpful online resources or courses that you found to get there?
So, oh man, I get to plug people. All right. So there's a course called Deep Learning and Computer Vision with Python by Adrian Rosbrock. It's very interesting, specifically related to deep learning with computer vision with Python. There is a YouTuber who he's a bit high energy for some people, but Siraj Raval explains things very, very well in like something that I was able to understand. From there, there's a lot of great intermediate to entry level authors. Francois Chalet's Deep Learning with Python is like, it's the best. And you can just kind of continue on from there, but it's all very accessible. It's just hard to go from, what is this, to reading like academic papers, but you can kind of bridge the gap. Absolutely, yes. Or Sarah, yes, absolutely. Stanford, thank you. Is that
Hate to not ask a question, but just an addendum. The Nazis didn't develop the nuclear bomb because they thought it was too risky of an endeavor, in the sense that it was not likely to succeed by the time because the war would come to an end. So they abandoned the project because they didn't see the chance of it succeeding, but we never knew that. So, and the same circumstance isn't the case here with machine learning. I mean, it's not being developed in the circumstance of a war, so you're probably right about the someone else would probably develop it.
I appreciate that. That's interesting and scary, and that kind of thing is, nightmare mad science. And, you know, hopefully we don't get evil, autonomous AI botnets, but, you know, if we do, it's going to be cyberpunk as fuck. Thank you, everybody.